Hi everyone. Today we will discuss something about paging. So, what is a paging? A paging is nothing but it is a memory management technique. And here, what we are going to do is we are going to divide the process memory into different blocks or different parts. We simply call it as page. Okay. So here, what we are going to do here it's given. So the process address space. The process address space. What's a process? Process is nothing but it's a program to be executed. Okay. So a process address space is broken into different blocks. We simply call them as pages. Okay. So the size of a process purely depends upon the number of pages. If the number of pages are more in number, then we can say that the process size is more. If the number of pages are less, then we say that the process size is less. Okay. And moreover, the size of each page should be one and the same. Let us suppose if this is a process, let us suppose this is a process. Okay. So the process space is divided into number of pages. Let us suppose here this is a page. Page 0, page 1, page 2, page 3, page 4, page 5. Let us suppose this single process is divided into 6 pages and the indexing started with page 0. Page 0, 1, 2, 3, 4, 5. Okay. And the size of each page should be one and the same. Means the size of each page should be equal. Okay. Right? So that's why the author has specified the size of the process is measured based on the number of pages. Similarly, each page should be the same. Okay. So here what we are discussing, what is a page? A page is nothing but a process. The process page should be divided into number of pages, and the size of each page should be equal, or the size of each page should be the same. Okay. So similarly, like page, similarly in main memory. So in main memory, also let us suppose this is main memory. Let us suppose this is main memory. In main memory also, the main memory is also split into different parts. Okay, different parts, and we name it as frame. Frame. The main memory is divided into frames. Okay, see, the main memory is divided into fixed size. Here also it is divided into number of frames, and the size of each frame should be equal. F0 means frame 0, frame 1, 2, 3, 4, 5, 6. Here also the size of each frame is one and the same. Okay, see here, the size of frame is one and the same. And moreover, coming to the size of page and the size of frame, the size of all pages should be same. Okay, the size of all frames should be the same, and the size of page and frame should be one and the same. Why? Because if a process is divided into 6 pages, let us suppose if a process P1 is split into 6 pages. And the reason why we are splitting a page into, the reason why we are splitting or dividing a process into number of pages is, suppose if we want to execute a particular process, if the process is large in size, then it is very difficult for us to copy or to send this entire process into the main memory. That's why what we are doing is, we are splitting that process into number of pages. And whatever the page we want to execute, that particular page only we are inserting, or we are sending, or we are copying into the main memory, and then that particular page will be executed. So here, if you listen, so here process, that will be split into number of pages. What are all these? All these are pages. Pages. Page 0, page 1, page 2, page 3, page 4, like that. So we have main memory. So the main memory is also split into number of frames. frames, like frame 0, frame 1, frame 2, frame 3, frame 4, like that. So, whenever a particular process is treated like this, if we want to execute a particular page, we have to place this page in the main memory. In the main memory, where we have to place the entire memory is split into number of frames. All the frames are equal size. All the pages are of equal size, and the size of the page and the size of the frame is also equal. Okay. Size of page is equal to the size of frame. The size of page is equal to the size of the frame. Okay. Why? Because I have told no. So if you want to execute this particular process, let us suppose this is P1. If you want to execute this process P1, we got insert this entire process inside the main memory, because the memory may not be sufficient. The size may not be available. The required memory size may not be available in the main memory. That's why. So what we are doing is we are splitting this entire process into different parts. Okay, we simply call them as pages. The size of each page is one and the same. Okay. So since if you want to execute page 2, that page 2 will be transferred into the main memory and it will be placed in a particular frame. Where to place that will be decided by the page table. We have another concept like PageTable. We will see that. Okay, a page table will take the page number as the input and produces the frame number as the output. Okay, let us suppose where page 1 has to be placed. Where page 1, we are giving page 1 as the input, because we have defined just now. A page table will take the page number. It will take the page number as the input and produces frame number as the output. Where page 1 has to be placed, that is the input we are giving to the page table. And it will tell, yes, it has to be placed in so and so frame number, like that. Okay, we will see. So if you see roughly here what we are doing is, this is a process. This is a process. Okay. So the process is divided into, see here, the process is divided into number of parts. It is divided into number of parts, and each part is called a page. Page 0, page 1, page 2, like that. Number of pages. Okay. So a process P is split into number of parts, and we named that part as a page. And the size of each page is one and the same. The size of page 0, page 1, and so on. All the pages are of equal size. Okay. Similarly, main memory. So we have already specified in main memory, we have only two parts. The first part is for operating system. The second part is for user space. So if you remove this, so in the main memory, the first part is for the operating system. The remaining part is for the user space. The remaining part is for the user space. So we have the main memory is also split into number of parts. Okay, number of parts. Each part is called as a frame. Each part is called a frame. Okay. So see, page 0 is to be placed in here, frame 2. Okay. Page 1 in frame 4. Page 2 in frame 3. Page 7 in frame 5. Like that. Page 4, let us suppose, page 4. Page 4. Page 4 is already placed. Okay. Let us suppose we place it as page 4. Let us suppose page 4 is placed here. Like that, we can place them. So here they have started giving the frame numbers here. So they have missed this one. So this should be F0, this should be F1, F2, F3, F4, F5, F6, and so on. Okay. So this is secondary one. Okay. So what are the available pages? What are the pages to be executed? Those pages will be placed in the main memory. The remaining we need not store in the main memory. Only the pages which we need to execute, only those pages we will place them. Okay. The remaining unwanted data or pages we will place in the secondary memory. Okay. Right. This is the rough structure. So here, the entire process. The process is split into different parts, and each part is named as a page, and all the size of each page is one and the same. The entire main memory is divided into number of parts, and each part is named as a frame. The size of each frame is equal. The size of all the frames are equal, and the size of page and frame is equal. Okay, right? Okay, next. So next, address translation. So this also is a part of paging only. We are discussing about paging only. So here what they are already specifying is the page address consists of a logical address. The page address is called logical address. The paging, okay, normally we know CPU specifies a logical address, whereas main memory specifies physical address. This we have already discussed in the earlier classes. CPU specifies logical address and main memory specifies physical address. Okay, right? So here they are already telling that the page address is called logical address, and it is specified by page number and the offset. So page number is specified with P, and the offset is specified with the D. See, logical address. We have discussed CPU specifies logical address. That logical address here is represented with page number P, page offset D. Similarly, frame address is called physical address. Main memory will be specified with physical address. Okay. So see, physical address consists of frame number F, page offset D. Okay. We will see that. Okay. Right. So here what we are discussing, logical address is specified with the page number and offset value, page number and page offset value. So it will be specified with P and D. Similarly, physical address is specified with frame number and offset value, frame number F, offset value D. So this is the structure of page table we have discussed. Okay, this is the structure of page table. So here, this is, let us suppose this is a process. This is a particular process P. So that process is divided into different parts. See, it is divided into 4 parts. Let us suppose we have named it as page 0, page 1, page 2, page 3. Okay, this is a process. Similarly here, this is main memory. Okay, so the main memory consists of, let us suppose, it is split into 8 parts. Okay, right? So we specify this as, okay, this main memory is split into 8 equal parts, and those we simply named it as frames. Okay, these are the frame numbers. Frame number 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have started the indexing with 0. 0 to 7 means 8 equal parts we have. Okay, this is page table. We have already specified the page table. The page table will take page number as input. Okay, the page table will take page number as input and produces frame number as output. Okay, this is what happens in the page table. See, this is page number. Okay, 0, 1, 2, 3. These are page numbers, and this is frame number. See here. So page 0, where page 0 has to be placed, it should be placed in frame number 1. See, frame number 1. These are frame numbers. 0, 1, 2, 3, 4, 5, 6, 7. These are page numbers. frame, page 0. Page 0 has to be placed in frame number 1. Yes. Page number 1 should be placed in frame number 4. Where is 4? 4. Page number 1. Okay. And page number 2 is to be placed in frame number 3. So page 2, frame number 3. So page number 3, frame number 7. So frame number 7, page 3. Okay, this is what we do in, this is the overall structure of a page table. Okay, because you should know the structure of page table. Okay, so here what the page table is doing, the page table simply it takes the page number as an input and produces frame number as output. Okay, so we have seen the rough the structure of page table. So next comes an example. We will see a simple example for paging. Okay, this is an example for paging. Let us suppose this is main memory and it is 16 KB. Its size is 16 KB. So we have splitted that into 16 equal parts. Okay. So one frame, see here, one frame, 1 KB. So the frame size is equal to page size. So the size of each frame is 1 KB. The size of each page is also 1 KB. Okay, let us suppose we have 4 different processes, P1, P2, P3, P4. P1, P2, P3, P4. Each process is divided into 4 pages. See here, 4 pages. 1, 2, 3, 4. This also 4. 1, 2, 3, 4. 4 pages, 4 pages. So that's why we have inserted these 4 pages inside the main memory. So this is process P1, these 4 slots, and these 4 slots are P2, and these 4 slots P3, and these 4 slots P4. See, P1 is inserted in the main memory. Next P2 is inserted. Next P3, P4. Totally, all the 4 processes were inserted inside the main memory. Okay. So now the main memory is completely filled with all the processes. There is no hole, means there is no empty space. Okay. So now what happens is, so we are discussing the paging. Now what happens is, if 1 or 2 processes, let us suppose if 2 processes gets executed completely, then we can remove those processes can be removed from the main memory. Thereby we can insert some other process into that empty space. See here. So in the next example, see. So process 2 and 4. Let us suppose process 2, process 4 has completed its execution. Okay. So now what we can do? We can insert, see, process 2 here. So process 2 is finished execution. Next, process 4 is finished its execution. Okay. So what happens? These two slots will be made empty. See, these 2 slots may be empty. First 4 P1, next 4 empty, next 4 P3, next 4 empty. See here, in that empty space, we have a new process, and the size of this process is, the new process is P5, and here the process P5 is divided into different parts. Okay, we simply call them as frames now. So here it has 8 frames. So here we have removed process in the previous example. We have removed process P2 and P4. So totally 8 spaces were there. So in that 8 empty spaces, what we have done is, in the first 4, the first 4 of process P5, okay, the first 4 placed here, the remaining 4 placed here, okay, right? We will identify the empty space and we will fill that with some new process which are to be executed. Okay, this is the way what we do in paging. Okay. So next we will see the paging hardware. Next we will see the hardware, paging hardware. See here, CPU, we already discussed. CPU produces logical address. CPU produces logical address. So that logical address consists of P and D, where P specifies page number. Okay, right? D specifies offset number, page offset. Okay. So based upon that, this offset, okay, this offset and this offset, both should match. Okay. So this page number. So this is page table. This is page table. So what we are doing? Based upon the page number and its offset, we are going yes. Yes. Here this is the page number, and here we will have the frame number. We have already discussed the page table. It will take page number as the input and produces frame number as the output. So based upon that, okay, that frame number we will give here, and based upon that, we will go to that particular address location in the main memory. Okay. If you want to retrieve, we have two operations like read operation, write operation. Read operation means we will go to that memory location and we will read the data, or we will fetch the data. That is reading. Suppose write operation means what? If we perform anything, no, we will store the data in that particular address location. Okay. So this is what happens here. Okay. This is paging hardware. Okay. With this we will wind up the session. Okay. Thank you.